Hello, everyone. So last week we were a bit rushed towards the end. We spent a bit of time trying to debug and get Git and R in RStudio all set up on everybody's computers. So there was a few things I just wanted to make sure to touch base on and go over from the week one material about actually coding and programming in R that are going to be sort of critical foundation pieces for what we're going to do in week two and everything else going forward. So 6 specific things that we're going to touch on, and they are outlined here on my R script. The first thing is objects. So you might have heard the phrase object-oriented programming language before. R is an object-oriented programming language. Python is as well, among many other languages. An object simply means that you store something under a particular name, and then when you ask for it by name in your script or while programming. There's also, as I'll show you, there's objects that are perhaps hidden from your view that are sort of preloaded or pre-embedded in R. So when we talked about the calculator features, like we talked about how you can calculate the exponent, run something like exp2, so the exp function is an object in R. And so if you type, and so when you say exp2, R knows, oh, I'm calling this function that does this specific thing, and it's already pre-saved. So the convenient thing for you then is that you can create your own variables and functions. And so you can say something like, I want variable A to be the number 2. Now, anytime you call A, R says, hey, A is the number 2. It doesn't necessarily have to simply be a given number. You could say this object is a list of numbers. Talk more about lists of numbers and other features in week 2, actually. So in this case, I said, hey, R, I want you to store the object A, and I want you to know that A is 1, 2, 3, 4, and 5 is this collection of 5 numbers. So now if I ask for A, it's going to say, hey, here's what A is. It's these things. Is this collection of 5 things. An object can also be a string. So a string is simply a text that is embedded either in single quotes or double quotes. So the key is that you have to have a quote on each end or R breaks. So if you have one, you say this, see, it thinks this whole thing below is all part of the string. The string, it can be any sort of arbitrary character, right? And so in this case, it's kind of a crazy string because I threw a bunch of functions and spaces and line breaks all in it. But now I could say weird string that. And now anytime I type weird string, enter, it's going to say, hey, that's that string you saved. And so that string is synonymous with the object. And we can test that. I can say weird string equals that thing, and it'll say, hey, that's true. These are actually the identical thing. One just has an object name associated with it. So why work in objects? So there's a few valuable things about this. One, these are stored in your current programming environment. So here I already wrote an object called A, and I wrote an object called weird string, and we can use tab completion to find things. So in this case, there's not much to remember. It's pretty easy. But if you are working on some long data analysis project, you have a lot of different objects stored, a lot of strings, don't always necessarily remember how you spelled things or wrote it, and you might have really long things that are just kind of a pain to complete. And so I can start typing, and if I hit tab, so first off, R is going to say, hey, how about all these other hidden functions that are already uploaded that start with WE? And I can say, I don't want any of those. I'm going to keep typing. And so I hit tab and I keep typing. And so now I've typed WEIR, and R says, well, you want one of 2 things. You either want that object you created called weird string, or you want this weighted residual function. Maybe it's not quite the same match. In this case, I want weird string, so I'm just going to hit tab and it'll totally complete. And so now I have this object again without having to type the whole thing. So I can type weird string and it exists, or I can type tab and it'll complete itself as well. So I want to highlight one last thing about tab completion. You'll see if I type WE and hit tab, it shows me all the options. Once I get to the point where there's nothing else it could be, if I just type WEIRD tab, it's going to complete weird string because it's unambiguously the only remaining option. There's nothing else called weird something that's already programmed in R. Whereas if I made a second one, I said weird string 2, and this was second string. If I try and do tab completion, I type weird and I hit tab, it's going to say, well, I'm not totally sure which one of these you want yet. It's not unambiguous because they both start with weird. Okay, so next feature about that. So we talked about tab completion and how to find objects by name, which raises the next question. How should we name objects? The way I've done it here with simple letters and calling things weird string is not super helpful, but you'd be surprised how easy it is to make terrible object names and get lost in all sorts of object name soup when you really start to work on projects. And so it's helpful to think about a few conventions. Everyone has a different style. So really the most important thing is to pick a style and stick with it. So some people prefer a style where they put underscores between the different names of an object. So we could call this like, we'll say EPA 2018 data set. So I put underscores there. Some people prefer a title case type format. It's like EPA 2018 data set. Some people might prefer to keep the first lowercase and then capitalize things after it. Some people use periods. I'm not a big fan of that. And I think that's perhaps less important thing is pick a format and stick to it. It is a couple of things. One, it helps people understand and track what's going on in your code. But two, if you can pick separate formats for different types of objects, that can also be really helpful in the long term. So if you're making a function, and so we'll make a quick function here. We'll say my new function is so my new function is to take a number and square it. So if I say 2, it should output 4. Not a very helpful function because we can just square things on our own. But in any case, so if my convention for functions is I keep the first word lowercase and any word after that uppercase and then no spaces, no underscores, I might then use code data objects with underscores so that when I'm looking at my code, I know anything that looks like this is a function, whereas anything that looks like this, so EPA underscore 2018 underscore data set, is some sort of data object, or it's housing numbers or words or letters or something like that. And so again, your style can be whatever works best for you and whatever you find more intuitive. We just recommend that you pick a style and stick with it for whatever it is you're doing. Okay, 3 last things. First off, help files. Everyone needs the help files. All you have to do to access a help file for an R package or a function is hit question mark and then type in the function. So let's pick exp again, since we've used that before, question mark exp, and run that line of code. And what you can see is that over here in the bottom right box, we get the help tab and it says, hey, here's the functions we have for logarithms and exponents. And then it tells you about what the arguments are to the function. It tells you maybe perhaps a little background about what's going on, the different options available. If you scroll down, it often has more detail for people who need more help. And at the very bottom, and often I just scroll straight to this, right? Because I don't need the references or the sources or anything like that. I scroll to the very bottom and look at examples. And most help files have an example. And that's typically my go-to first, because I just want to see how it's actually being used in code. Again, you probably don't need that for exponents, but when you're using packages that you're not really familiar with or that someone else has written, often you want that help file to understand what's really going on. A couple other features, you can use 2 exclamation points. And right now that is actually searching in sort of like the underlying like R internet database for that same thing and pulling up things. I don't tend to use the double question mark a lot. My preference actually is if I can't find it in the single question mark help file that's associated with that package and that function, I typically just go to Google at that point. Okay, I mentioned how you can insert items into functions, right? I showed that example, or I called exp2. And calculated the number. So the thing we want to cover is arguments to functions. And so that was an argument. So in that exp function, I actually hit tab and it'll show me, hey, this takes 1 argument and it has to be a number or some vector of objects. And we'll talk more about vectors next week, but essentially in this case, it means you can say, I want to feed in all 3 of these numbers and calculate the exponent of each one. So rather than 1 at a time, it did every number in that vector, and here are the results below. So exp is a very simple function. It only takes 1 input. There are other functions that are slightly more complex. So if we say mean, open the parenthesis, hit tab, and it'll show us that there is 1 argument you can plug in, and that is some set of numbers to calculate the mean. But then there's this ... further arguments passed to or from other methods. And this is sort of ambiguous and it can't really be covered in exhaustive detail here, but functionally what this means is that there are other settings that you can add, but you don't necessarily have to. So we can look at some of those. We'll hit the question mark, go to the help file, and it shows us some of the features that are hiding here are things like, do you want to remove NA values in your calculation? Do you want to trim extreme values in calculating the mean? Perhaps there's other features that you want to pass on as well. Again, I'm going to cut this short here because we're going to talk more about when we get into actually building your own functions, about setting default values, how to make function inputs, how to treat those things. We'll get lots of practice with different functions, but I just wanted you to be aware that functions in R do have some sort of input, and the way you add those inputs is to add features inside the parenthetical. One other thing to note is that if you don't say x equals 2, so if we call x equals 2, it calculates it, and if we just say exp2, it calculates the same thing. So what happens there is, since it only takes one input and it's the first one, if you just drop a 2 in there, R assumes, hey, what that actually is a shorthand for x equals 2. If you have a more complex function, this doesn't always work, right? Because you'd have to make sure that you got it in the same order. So if exp actually took a y and a z, and you wanted to say z equals 2, if you just called exp2, what R would think is, oh, x equals 2 rather than z equals 2, because it just starts looking in order since you didn't specify anything. Again, this will become, I think, a little more intuitive once we actually start using functions, particularly functions that have lots of different calls. But for now, just to be aware that if you throw things into a function without specifying what the input is, R will still try and do something with it. And so that's something to be mindful of and be careful. Okay, and then the last item are messages, warnings, and errors. So 3 categories of times where R is trying to throw some sort of signal to you and give you a little bit of help. So a message is where R tells you something that isn't necessarily a problem, or it's not sure if you want to be aware of, but it says like, hey, long term, like this is something that is relevant. So the type of message I often get is if someone has updated a package I'm using and I have not updated it yet, and I'm using functions in that package, it might say, hey, just so you know, there is a newer version of this, and at some point this older version will stop working. So this is what you did works just fine. This is all accurate and good, but at some point it will no longer work. Okay, so pivoting to warnings. So as I mentioned, warnings are sort of the next level where it's like, hey, this could be a problem, not totally from the week 1 lecture materials. So trying to take the log of a negative, right? We know log of a negative is a bad time. In this case, we're saying, hey, take the log of -2. And R says, hey, that's not a thing. So we assigned it NA, and it says, hey, warning, when you tried to calculate this, it produced an NA instead. And you're thinking, well, why do I need to know that? Because I know I called the log of 2 here and it showed up as NA. You wouldn't necessarily know that if you did this, right? Because when you assign an object, you're not saying print it to the console. You're saying assign this value. So you're saying log of a negative is now an object that takes the value of this call log -2. And so nothing prints out. So if it didn't give you the warning, you might not be aware that there was essentially this bug that was feeding in an NA into your code and maybe throwing off some values way down the line. And so R is saying, hey, here's what we did. Sometimes a warning is not a problem, and it actually is what you want to do, or at least it's something that you just have to, you know is going to happen and you want to move on. But sometimes it's like, oh, I have an NA in there. That's something I need to be cognizant of. So the temptation is often to ignore warnings because the code still works. And I would just encourage you, never ignore a warning that you are not already aware of and okay with what is happening or why the warning occurred. So when you see a warning for the first time and you think, great, my code worked, I bet this warning's not a problem, resist that, read the warning, have a think on whether it's a problem or not. And so once you know it's not a problem, then you can kind of ignore warnings at least somewhat. But in general, when you see it, don't just accept that your code worked, take a look back and see what's going on. Okay, so then the final stage are actually errors. And let's see, oh, we're on the wrong side here. So the example that we showed here was taking the log of a word in the code from the week 1 tutorial. So in this case, we're saying take the log of the string a word, and are saying that didn't even work at all. You didn't try and ask us to take the log of a number. So when we asked for the log of -2, it said, hey, this number produces an undefined value. Here it's saying you didn't feed a number in, so it didn't even work as any sort of value. And so in this case, we were trying to say, log of a word, and it's not going to work. And so we know it didn't work because if I try and say, hey, show me what log of a word is, it doesn't show me that value. It simply says, hey, I didn't find that object. It was never created. And that's really the distinction between an error and a warning. Is a warning, the code still works, does what you told it to do. It just warns you about it. When an error happens, it breaks and it says, hey, this object wasn't created because there was some sort of error involved. If you get really into programming in R, you can alter behavior. So sometimes when I'm debugging, actually, I alter warnings so that warnings break the code as well. And so if a warning occurs, it stops just as if an error occurred. But I would recommend not changing those right now and just sort of be aware that when an error happens, essentially the code stops. And when a warning happens, it keeps going. It just says, hey, you might want to take a look at this. Okay, so that sort of covers some of the background that we weren't able to get to in week 1. So hopefully you have a chance to review that and let us know if you have any questions before we fully move on.